Hey,
Oh,
how's it going?
good. How are you?
Good, good. It's like not a bad time in Australia right now, right? I always ask
No,
you,
it's good.
and I'm always
It's
like,
10 a.m.
yeah. I feel like I ask you this every time we do these, and then it's always like, oh no, it's good.
So good.
Let's see. Oh, here are people.
How are things over yonder?
Good. I think that Grayson got me sick.
Oh,
Yeah, pretty pissed.
too many makeouts.
Yeah. Basically, it's a result of us just making out nonstop.
Yeah, well, I can understand it. Both very attractive men. It's reasonable.
Rudd in the chat. Rudd here from the country below sea level. Whoa. Now I have to Google this. Countries below.
Is this somewhere in Europe
level.
or South America?
Yeah, let's see.
Oh yeah, do you have the YouTube link somewhere?
Yeah, let me drop it in for you. Oh man, this is crazy. Countries below sea level?
Yeah. There's a lake below sea level somewhere in Australia as well. Which is a bit ironic.
Hello, Shannon Catalano. Let's see if this works. Oh no, I can just, it's right here. Here's the death note. Put it in the chat. Rudd, oh man. Wait a minute, Shannon, are you coming in from an island in the Pacific? That's pretty cool. And Rudd, I'm super curious now. I'm gonna put you on the camera, Graham. I don't want to be on the camera.
I don't want to be on the camera either.
You're on the camera, buddy.
Oh no. Good morning.
Well,
I don't know what everyone else is drinking, but I have coffee because drinking before 10:05 a.m. is a sin.
Is
Give me 5 minutes.
Drinking coffee before 10
Oh no, drinking booze.
Oh yeah.
I have to wait at least 5 minutes.
Oh, so
Once
now
the
you're
stock market opens, I can drink.
in 2 minutes. You're going to be drinking booze, basically, is what you're saying.
Yeah, I'm just gonna go off screen and get some schnapps or something.
Right. That's sad. That's really depressing. It's not. It's not. You can live your life the way you want to live. Where are people from? I'm always amazed at where people are located in the FaceTime audience, because I think that something like 180 countries are represented in the audience. We're just waiting on Matt.
Classic Matt.
Classic Matt. David is from San Diego. Truly is an international show. Vegas. Roy Fritz is from Vegas. You guys, we're not well, at least I'm not an important one. My name is Eric. I'm one of the producers of Space Time. And Graham, coming in here from Australia, is one of the writers. Graham is a quantum physicist, brilliant writer, brilliant scientist, and we're really lucky to have him as a collaborator on the show.
Thanks, Coach.
Right?
Yeah.
That's what I'm here for, man.
Yeah, great.
Yeah, great.
So it's just us three so far in this hangout, right?
Yes. Jens, how's it going? No, there's
yeah, great.
There are a bunch of people watching on the live stream as well.
All right.
And it's us here now, and we're waiting for Matt.
Great.
Thank you for joining us.
Yeah. I somewhat expected this to be quite crowded, and yeah, that's so.
Not. It's, you know what?
Is it?
It's sometimes there's, sometimes there's 20, 30 people on the live stream and 5 or 6 people on the hangout. But sometimes we just happen to schedule them during busier periods where people are just less available. But it's shocking, because there's 1.5 million people that subscribe to the channel, and then a lot of people that support on the Patreon and that get these invites. But people are busy. People are busy. They don't want to come and hang out with us, which is shocking because we're such amazing individuals.
Yeah.
So anyway, I'm just pinging Matt to see where the hell he is. Jens, you just joined the Patreon. Where are you stationed? You're in Europe, or?
Yeah, in Germany.
Okay.
Yeah, so it's 12 o'clock in the night.
Yes.
Right now for me. Yeah.
Yeah, 6 hours difference. It's exciting. I guess it could be worse.
Oh yeah, sure. Yeah, sure. It can be
great
worse.
either.
Yeah. So I'm going to bed right after this. So.
Exactly. What part of Germany?
Near the Netherlands.
Okay.
There's a number of cities there.
One of those like extremely international cities where everybody speaks like 5 languages.
Yeah, well, I guess we have lots of Turkish immigration here and other Middle Eastern stuff, I think. Yeah, certainly. But it's not a problematic region or something like that. It's really, I think it's cool here.
Oh no, I was more thinking like I feel like there are border cities like in Germany and the Netherlands where everybody speaks like German, French.
Oh, and it's not that close. It's not that close. No.
Oh, okay.
Yeah, it's not. I can actually travel to the Netherlands with my monthly ticket for public transportation. So it's
pretty cool.
But it's still not. It's not the neighboring city or something like that.
Not quite that close.
Yeah. Yeah. Do we just want to start or something? I'm not really sure. I kind of expected to pop in here and have, I don't know, half a dozen other guys asking lots of questions.
Well, there will be lots of questions once we get going.
Right.
I promise. But we don't. I typically, I don't want to start until Matt gets here.
Yeah.
So hang tight. And my apologies.
No troubles. So what time is it for you now?
It's 6:09 p.m. in New York City.
Right.
So it's a reasonable hour.
Yeah.
David Leonard wants to talk about Oumuamua until Matt gets here.
Whether it's a spaceship or...
I really like how bold the Harvard he's like the director of the astrophysics program at Harvard, and he's just like, It's a space probe. Completely confident, you know.
Well, maybe it's a joke or something.
I don't think so. I think he's just
No?
like, he's just really hardcore, even though the evidence suggests otherwise.
Yeah, sometimes you're surprised what people think.
Exactly.
Yeah.
Despite the evidence. Oh, Stevie himself, you're in New York as well. What's up? Let me call Matt. Let me see if everything's okay. 1 second. Usually he is not late, so.
Be right back.
Oh, okay, great. I just talked to Matt. He's just running a little bit late. He's logging in now.
So the live stream is on YouTube, right? You can.
The live stream is it's a private stream that goes out to some other Patreon tiers as well. So it's all kind of Patreon subscribers only.
But is it all right? And what's the platform doing the streaming?
It's Google Hangouts. Yeah, the platform is Google Hangouts, and we're able to access that through the Spacetime YouTube channel and provide like a Hangout for people that can come in on camera, and then we also have a live stream link that we can send out to everyone, and they can ask questions in the chat. So it's pretty decent. It's not the best system in the world, but of all the different options out there, it's pretty good. It's gotten better over time. I have my small complaints, but whatever. It's free. I can't complain too much. Yeah. So. I'm pinging everybody to get some questions together. And Jens, I'm sorry, there's usually 2 or 3 other people on the Hangout itself. But yeah, it seems to be one of those times where it's very quiet. One of our mainstays, Tambi, emailed me and said that he wasn't able to make it because of work. And so, you know.
No worries. No complaints from me then.
I feel like I'm letting you down, essentially.
Well, it's not a problem. I mean, it's better. I mean, of course, completely. It might be more fun with more people, but in the end, I can ask more questions then.
Oh, there's
Hey,
Matt.
can you guys hear me?
We can.
Yeah.
Phew. Hey,
Matt
sorry
is-
about that.
Matt is at a rave right now.
I'm at a rave, yeah. Hence my lateness. You know, all the raving.
I was more interested in like the purple LED light that's kind of glowing all around you. It's awesome.
It's this thing.
Oh my
Isn't
God.
that cool. Whoa.
Did that come from Oumuamua?
Oumuamua. What?
I said, did it come from Oumuamua?
Yeah, this is an alien life form that I've I've killed and hung from my ceiling as a novelty lamp.
That's what we would do if we encountered any aliens.
Yeah.
We would just kill them and hang them from our ceilings.
For cute decor, absolutely.
Okay, let's get started. So I'm Eric. I'm one of the producers of the show and one of the owners of the production company that produces this show. Graham is on as well, in from Australia. He's one of the co-writers of the show. He's a quantum physicist, PhD. He's amazing. And Matt's here, of course, the host and writer of the show. We have a lot of amazing people in the chat on the YouTube, and we have Jens Thiessen. Is it Thiessen?
Close enough.
Well, tell me how it actually is supposed to go.
I pronounce it Tyson.
Tyson. Is it
Yeah.
Jens or Jens?
Jens.
Jens
With a
Tyson.
soft-
So
soft J, yeah.
a new Patreon supporter. Thank
Hey,
you so much.
Jens.
Tambi is not able to be here. Tambi is usually here providing, his very important contributions, but he emailed and said he's not going to be able to make it. So a little bit of a
Oh
small-
man.
I know, right? But yeah, so let's get to it. I'm just perusing the chat to kind of catch up on the questions that have been.
Actually, can you share the YouTube link? I can't access it easily.
It's in the Patreon. It's in the Hangout chat. It's
Okay.
that second link in there, on the right side of the Hangout. Yeah, it should be there. Find it.
Not yet.
I can
don't
email
see
it to you as well.
Good mind.
Yeah, there's a chat in the main Hangout that we're in right now. If you can find that, then it will appear, and I'm going to email it to you right now as well. There you go. All right, just sent it. Okay, so a gentleman named 6CEF, who actually had to leave the chat, but asked a question. Is it possible that there's a mathematical system like QFT or string theory, which is somehow complete enough to describe any valid universe?
Whoa.
Big question there. Not going to be a great answer, I'm sure, but what do you guys think?
And I maybe need to define valid. So being a smartass, I would say, of course, because if it describes the universe, it's valid. But I think the question is probably deeper than that. And it sounds like it's a good question for someone like Max Tegmark, who thinks that all possible mathematical universes exist, and indeed every kind of
Did we lose Matt? It's frozen in time. I don't know.
do you hear me say those things?
We lost you for like 10 seconds.
So I was saying that this is a good question for someone like Max Tegmark, who thinks that if a universe can be represented in a mathematical way, then it exists, and that all possible mathematical representations exist. I guess the answer is yes, but I don't think there's any way to even start to ask whether that's right. It's I know, beyond speculative. What do you reckon, Graham?
So maybe I'm understanding the question incorrectly. I thought it was sort of about, is it about, does such a theory exist, or just the possible existence of that? Where was the...
I think is it possible that such a theory could exist? Could there possibly be a mathematical system which would be complete enough to describe any valid universe? So not necessarily one that we know of, but would it even be possible for there to be one?
Oh, yes. Okay, so now I understand what Matt meant about what do you mean by valid. So Yeah, I mean, there are some. The assumption of most of science is that when you sort of do science, you converge on a single answer, and that there is a single theory or underlying sort of truth that you approach. So if you have a single universe, whatever it is, then you should be able to describe that mathematically, barring some weird sort of outside supernatural influence, I suppose. But yeah, that's definitely Max Tegmark's kind of idea. I think, yeah, whether or not all universes are mathematically describable is kind of an interesting question. I don't know. There's probably a relation to Gödel's incompleteness theorem somewhere here about can you define a mathematical system that doesn't require external axioms to sort of prove some sort of external input. I'd like to think all universes can be described mathematically, otherwise physicists are going to be out of a job at some point. So
You were just born in the right universe, Graham.
yeah, exactly. This is just fine-tuning. The fine structure constant is tuned for me to exist in a universe that seems to be so far mathematically describable. We might run into problems with that at some point.
Yeah. This is. Let's start with one of the unanswerable questions. Cool.
Yes, exactly. My coffee hasn't sunk in enough for that one yet, I think.
Dustin Edgman asks if there's any chance of an episode on gauge theory.
Well, we sort of did one. That was the, I guess we can post a link in chat. That was the gauge invariance and the standard model. Something like that was the title.
Yeah, I think it's the only one that has gauge in the title. And Graham led the writing on that one. I think it's great. But we might go further. So this one focused on...
Is it quantum invariance in the origin of the standard model?
Oh, yeah, maybe it doesn't have gauge in the title.
Oh, damn.
Here, I'll pop it in.
That might be it, actually.
Here it is.
It definitely focuses on electromagnetism and how the electromagnetic force arises due to gauge symmetries, due to its gauge symmetry phase invariance. So yeah, maybe that's, yeah, I think that's the one. But we talked about going further about doing the other gauge forces, and we may.
Yeah.
That might be a little bit down the track, though.
This is an interesting question. Just a minute, I want to. Here it is. Femtus asks, could you do an episode on conformal cyclic cosmology?
I'd have to learn what all of that is first. But
Conformal.
Yeah, I need to remind myself.
Is this Penrose's?
Yes.
Yeah.
I'm reading the Wikipedia. The universe iterates through infinite cycles.
Yeah, I remember there was a paper by him a while ago about I don't know if he found, but he proposed some way to measure if this was true. Each cycle would leave some sort of imprint on the universe that you could count, kind of like tree rings. I don't know if that was ever found, though.
Crazy.
I mean, we could. I think that'd be a little bit down the track.
When you say so, like, talk about the track a little bit, so people know like where your headspace is in regards to trajectory.
Well, let me. That's a good idea, and let me get to that in detail then. But the reason we might not jump on this immediately is that although Roger Penrose is a genius, he has, in the latter part of his career, there have been many quite out there ideas. He's a big supporter of the entangled tubules in your neurons as an explanation for consciousness. and against any reasonable evidence that you actually need quantum mechanics for consciousness, and the conformal cyclic cosmology. I mean, to me, it really sounds like he just doesn't like the idea of there being a beginning or an end of the universe, rather than there actually being any sort of physics-based reason for proposing a cyclic universe. But I need to read more about it to really decide if that's if that really seems to be the motivation, or how much is actually in it. But yeah, I mean, it's the sort of thing that'll be fun to do as a review of some of the quirkier cosmologies that are out there. So in terms of the track, so we've laid the ground for a lot of the stuff that we'd been planning for a long time, and have actually done a lot of the really satisfying stuff, and that's really opening the door to a lot more, to some new tracks. But before brand new tracks start up, we really haven't finished with string theory yet. We need to probably maybe do a whole episode on M theory, but certainly CFT correspondence, and that's essentially a holographic universe episode, but there may be a further one on top of that. So we've got at least a few down that track. And then the other thing that we laid the ground for that we never really did properly are, two things really. One is vacuum decay, the awesomeness of vacuum decay, and what is a false vacuum, and that is very closely tied then to inflation, where you have these changing vacuums. The various theories for regular and eternal inflation require change, that these particles, these dilatons, rolling down your vacuum potential, and so we're going to dig deep, I think, into that aspect of cosmology, the very beginning of the universe. Ask if maybe the basic state of the universe is this rather insane sounding eternal inflation, in which our own universe just appeared as a bubble, perhaps along with many others. So that's in my head what the next set of quite hardcore things will be. But after that, the doors are then thrown wide open to all sorts of other things. Maybe we'll do a Roger Penrose track and look at all of his fantastic ideas.
It would be interesting to do an episode just on speculative cosmologies, to kind of run through some of the more non-traditional or obscure, without getting into like total quackery. But let's see.
Yeah.
Oh, David Leonard is asking an easy question. I am new. What are you working on now in your real job? As if space-time isn't a real job.
Ooh, that's a good question. So I'm working on getting over my jet lag. Still, just back from Australia just a few days ago, and still not sleeping. About to head back into semester, so start teaching in a couple of weeks, week and a half really, which sucks. But hey, in terms of research and that, I'm working on organizing a workshop. So it's on gravitational lensing of quasars. I'm trying to bring some people together to to think about the future of the field. So running a little workshop in February. So my sciencey brain is actually kind of doing administrative stuff, trying to organize people, convince them to come. that sort of thing. Yeah.
What's up in gravitational lensing right now? Like, what are the big problems that are trying to be solved?
Well, the really exciting thing now is that we have some telescopes that are going to come online over the next few years, which will completely change the field. In particular, some telescopes that are going to be able to survey the entire sky over every few nights. One of them, one of the most important being the Large Synoptic Survey Telescope, LSST. And these are amazing for lensing, for catching, in particular, quasars that are gravitationally lensed, so that you see multiple images of the same quasar around an intervening galaxy that's acting like this giant lens. And so when LSST starts working, we'll find, like, we currently know about 100 of these quasars, and they're all incredibly useful as tools for many different things, including studying the universe and studying quasars. But LSST will find several thousand, and so the whole field is going to be broken open, and it'll be incredible. So that's part of the motivation for the workshop, is to get some folk together and figure out what the hell we're going to do with all of this data, because we don't really know yet.
What do you are you excited about this, the brightest quasar ever seen that was detected?
600 trillion suns. Yeah, I mean,
that's just mind-boggling.
It's an insane brightness. We keep finding the brightest quasar ever seen. This one's very bright. Yeah, it kind of highlights a big problem that we already knew existed, was that the quasars in the beginning of the universe are way too bright, and their black holes are way too big. And we don't know how on Earth black holes could get that big in such a short time after the Big Bang fusing. And this one just kind of adds to that confusion. It's consistent with our confusion.
Are there any proposed reasons or rationales for how that could have happened?
Yeah, I mean, as soon as a new, weird thing is observed, you get 1,000 explanations. Probably aliens, most likely, we're thinking. But if not aliens, then different. The way that black holes feed may not be well understood. I think the favorite thing one thing you probably really need to do is, in the modern universe, when you make a new black hole, you make them when a particularly massive star explodes, and the core of that star then collapses on itself. And if it's big enough or massive enough, it collapses into a black hole. But there's a limit to how big a black hole you can make that way, because in the process of star formation, there's just a limit to how big those stars can get. When they're collapsing from gas clouds, the gas clouds tend to break apart, and so you can only get a star of a certain size. Something like 100 times the mass of the sun is about the maximum for newly formed stars in the modern universe. But in the early universe, it's believed that that these gas clouds, which were back then much purer, much less completely unpolluted by heavy elements, pure hydrogen and helium, and hydrogen and helium are able to collapse into much, much bigger stars. And so people are trying to run computer simulations to see how big those stars can be, but people think maybe you can collapse stars as much as 10,000 times the mass of the sun. Maybe they collapse straight into black holes. And if you can start by making what we call a seed black hole that big, then can then grow into the sort of really crazy quasar driving black holes that we're starting to see these days. That's one idea. That's got to be a part of it, but it's hard to do even with just that. So
even if you had stars forming on a huge order of magnitude larger than what we already have in the modern universe, it still wouldn't necessarily create the kind of size that we're seeing.
Yeah, so we're talking about the ridiculously large black holes that are confusing us are kind of around 500 million years after the Big Bang, so even a few 100 million years after the Big Bang. And so we see these very distant quasars, like this one you mentioned, this brightest quasar ever, and its light has been traveling to us for nearly the entire age of the universe, which means it must have existed soon after the Big Bang. And we figure out the mass of its black hole, and its black hole might be, many trillions of suns, even, which is really hard to understand how it could get that big in only those, say, few 100 million years since the Big Bang, unless you really stretch the physics, and we don't know in what direction we should be stretching the physics at this point.
It's clearly some sort of space battle, right? This really bright quasar.
Space what?
Space battle, right? There's some sort of epic conflict in the early universe.
It could just be aliens.
Yeah.
Like a giant black hole cannon.
Yeah.
Ooh.
This is actually the Death Star, because it's a long time ago, far, far away, right? We see delayed light. So
yeah,
George Lucas is actually just describing history.
Can I ask a question to this topic?
Please, Jens.
Well, first, this show has really it's really been great for getting a more intuitive sense of black holes and what they really mean. Especially this one episode that your colleague did back then when he was still hosting. So, really, what is really the reason why? No, better the other way around. First, it is true that there is some kind of duality between the cosmological horizon and the event horizon of black holes. They seem to be quite similar in many ways.
Mm-hmm.
So that's one of the things that seems to come through many of the episodes about black holes, even though it's never really directly addressed. So the similarity seems to be that the things that fall out of the horizon and the cosmological horizon and things that fall into a black hole, that's kind of the same maths, that appears to be the same kind of maths that's describing this. At least if I get this right on the survey. I'm not really digging into the maths of this, but there seems to be a lot of similarity there. Is that correct?
Yeah, that's as I understand it. Also, there are differences, but the imprint of what has fallen into a black hole, as seen by those outside a black hole. Okay, so we can trace the information of whatever's fallen into the black hole because essentially because of the time dilation at the surface of the black hole, in which you have in which you can express it as an inward flow of space at the speed of light, and then you have the cosmological horizon, which is the inverse. In a sense, it's an outward flow. That's right. That's a little simplistic, but you have due to the expansion of the universe, you have an outward flow, a spherical region around us where the space is moving away from us faster than the speed of light, and so you have a similar kind of frozen state to that as well. Or rather, at least you have photons emitted at that horizon which can never quite reach us, and you have photons just this side of the cosmological horizon which will reach us vastly redshifted. and those, that's a similar situation to the event horizon of the black hole.
And if you look at matter or objects you observe, if they drift towards the horizon, there's a limited amount of future you see for them, because time gets infinitely dilated, and you see up to a certain point in the lifespan of this object and no further. They freeze in time, apparently, and they do that for the cosmological horizon as well as the black hole horizon.
Yeah.
So
kind of
you get
conceptually
infinite
the how someone would perceive our universe from outside of our cosmological horizon. You're saying there's a similarity between how people would perceive things entering or approaching the event horizon of a black hole.
No, I don't mean how it is for those people who cross it. I mean for us, for the observer that is here unaccelerated, things that drift away from us towards away from our visibility. So we have a limited amount of time we can see for them,
right?
Because they can then get redshifted, time frozen, and dim. But it's really a time thing primarily. And with the black hole, it's the same thing. They get dimmer, they get more redshifted, and we see only a limited amount of time. So, first of all, this duality, I think, is intriguing in some way, because I think perhaps you can I can make an intuition out of it, and understand better how they look. Very helpful are these diagrams that I think Wikipedia has them, where you have this universe and the geodesics around the expanding universe, so you can see who sees what, this sort of thing. But what I really wanted to ask about the Big Bang here and these these black holes that don't exist. How would we even know? How would you even know what is in a black hole or not? Because if I think of the Big Bang as a big soup of dense matter around the whole universe, and then you get denser regions and less dense regions, and then gravitational effects are making perhaps black holes everywhere, or how is this supposed to? I mean, to what extent do people really understand? Is the math clear here? What happened? I mean, for example, can you exclude that the current world is into something that resembles a black hole on its own? I mean, we would then probably see a preferred direction of the universe, and we don't, I think. But there was this episode where you suggested that they do a thing as controversial or something, but it doesn't really matter. Even if you don't see a preferred direction of the universe, can you really exclude this kind of scenario? Is the math powerful enough to tell whether that could be the case?
Seems we lost Matt, so I'll try and field that. I think, so just to clarify, your question is how can we do a measurement to determine if we are inside some event horizon?
Yeah.
So one of the properties of first of all, our understanding of the space-time structure inside a black hole is kind of limited, because the singularity, by definition, is at the center, is something where physics as we know it kind of breaks down. So we can sort of guess at what the space-time is like. So for example, the singularity you see that is the event horizon is actually a bit of a trick of the coordinate system. You can change your XY axis definition to make that singularity go away. And we know that as you cross the event horizon, space is actually smooth. And so that's sort of not a real singularity. But the singularity at the center of a black hole is, you can't make that one go away. It's called a curvature singularity. And so if you were inside a black hole, one of the properties of being there is that all trajectories end at the singularity, even for light. And so it doesn't matter if you're inside a black hole and you shoot light rays in any direction, it doesn't matter. They will always end up at the center of the singularity. And so that you would be able to tell, because you would never be able to shine a light. This is to your point about a preferred direction in some sense. I would never, if the singularity was that way, I would never be able to shine a torch that way and have someone there detect it if they were far enough away. So you could do some sort of laser test, which is, you put a laser and you shoot it in the opposite direction to where you think the singularity is, and it would never reach your detector because it would curve and head back to the singularity.
But that's supposing that the effect is already strong, right? I mean, if I can envisage a black hole that is so big that curvature is locally flat, right?
Yeah, that could be true. I think, yeah, I guess if you say that the universe is entirely a black hole, I don't know if that.
No, not necessarily entirely, but I mean,
large enough.
The way I understand it, these mathematical solutions to the Einstein equations, they're so apparently so complicated that could it be that it's just some, I don't know, some nesting of tunnels, for example, and if they come shortly after the Big Bang, they could be potentially vast. So that's really, I have no intuition into whether that is obviously not the case or whether it could.
Sorry, what do you mean by nesting of tunnels?
Well, let's say if you have, I don't know, a black hole forms at one point and a couple of other points, and then more black holes form inside the new black hole, and so on. So it's a kind of nesting structure then. Yeah, that should follow. That at least I think it's kind of intuitively
I'm with you.
probable to me, but
can you guys hear me?
yeah.
I think your intuition's right. I think you can imagine a black hole so large that its interior is flat on the scale of a universe.
Yeah,
which is totally nuts.
But is it nuts? I mean, I'm not saying it's true or something. I'm just saying, what exactly do we know that we can exclude this scenario? Because the entire universe was once very small, right?
Well, I mean, one thing, the universe is expanding, so that's perhaps you can come up with a reason for a region interior to a black hole to be expanding isotropically. You would have to work hard to invent that, I think, but it may not be. There may be a way to do that. And the reason the early universe didn't all become a black hole instantly with its insanely high density is because of its expansion rate. Okay, it was expanding fast enough to not do that, and it also had a uniform density, so there was not a sufficient overdensity in any one region. You could imagine
it makes sense,
impossibly larger universe than our observable universe that wasn't globally expanding at the at the rate that our pocket was, but still had that high density, and then that global universe could form an event horizon bounding it, okay, and that would be a black hole, and parts of it could start to collapse, and perhaps our part of it is flowing with that collapse, but for some reason our little pocket of the universe is expanding, which is not what you'd expect inside a collapsing black hole, but there could be a reason why this little pocket's expanding. But that would not make the horizon of our universe the event horizon of a black hole.
Oh no, it wouldn't. No, that's true. I didn't mean to say that. Yeah. Well, yeah. I'm just probing to what extent there's clarity. That just yeah. So I take this to be that that's probably not obvious or something, right?
It's not something I think it'll be hard to rule out this proposal, but I think there's also no very good reason to accept that the universe elsewhere wouldn't be expanding as ours is.
You might be able to make some arguments based on the observed density, but if this is just a local pocket, then maybe that's not enough.
Yeah. I'm going to take
cool idea, though.
I'm gonna take a right turn to a question about quantum mechanics. Graham. Dustin Edgman asks, "What are your thoughts on quantum loop gravity and relational quantum mechanics?"
Ooh, I don't know much about relational quantum mechanics. I do know that Ravelli does cool stuff. In terms of loop quantum gravity, I don't know enough details of that as well in the sense of how it stacks up against string theory. I mean, it's really the only other contender to my knowledge of how to have quantum gravity. And I think it relies on, at some level, the discretization of space. So, yeah, I think the idea of string theory probably comes out on top, although at the moment it's a bit neck and neck for most people, in the sense that you can't rule one of them out. The strength of string theory is kind of its weakness is it's super adaptable, but you have this huge parameter landscape where you can't nail it down, and that's one of the main criticisms. But I think string theory has the ability to encompass the standard model of particle physics in a way that loop quantum gravity probably can't. So loop quantum gravity, I think, is mostly about gravity, and it works with existing quantum field theory rather than being overarching theory. So it depends if you want to do the trade-off of this large region of applicability, but too many parameters to tune. And I don't know to what extent what the state of play is for loop quantum gravity versus string theory in terms of who's closer to a testable prediction. I think probably LIGO has helped with that, but I'm not up to date on that. I don't know about relational quantum mechanics. I've heard.
Sounds like a good idea for an episode, and we definitely will hit.
It's this. Okay.
Quantum gravity at some point soon.
Here's another question from Tom Doherty. Do computer simulations for the rate of convergence of two galaxies include the massive dark matter and expansion due to dark energy? So,
yeah, if you mean collapse, you mean sorry, do you mean simulation of, say, collisions of galaxies?
Mm-hmm.
Yeah, Matt, I would assume so.
Well,
right?
I mean,
or these cosmological.
I just want to read the question. Where is this?
It's in the chat. Let me. Oh yeah, you don't have the Hangout chat.
I have it open. Oh, here it is.
Oh, I did. Yeah, you copied it. I'm gonna put my money on yes, because things like the Millennium simulation and all of that.
Yeah.
In order to get correct dynamics, you need to include the dark matter halo. Maybe on that scale, you don't need dark energy. It maybe is a small correction because it's not really. It depends how far away they are. I guess Milky Way plus Andromeda is probably not enough to have dark energy effects, right?
Exactly. I would guess if it's a pure simulation of two galaxies, then I think most of them would probably not bother with dark energy. I don't think it would be a large effect, but they may. But they certainly all use dark matter. Otherwise, they're badly wrong.
There's a question from David Leonard that says, "Do you believe there is a significant amount of mass from the Big Bang that is now outside our cosmological horizon? If so, how much?"
There must be, and we can put a minimum on it actually. And I don't remember what that number is, but the minimum size of our universe, of the greater universe, is assuming that our universe is closed, so not infinite. If it is closed, then it must have a positive curvature. Okay, it must be essentially like a three-dimensional version of the surface of the sphere, and that positive curvature should be measurable, given enough precision, by just looking at very large triangles and seeing if their angles add up to 180 degrees. The largest triangle we can look at is by looking at the cosmic microwave background radiation and looking at extremely long, skinny triangles from where we are up to the cosmic microwave background radiation, and features in the cosmic microwave background form the short end, and we can know that size, and we can know the distance, and so we can figure out essentially the geometry of the universe. And we see when we do that the universe is as flat as can be, which suggests that it's infinite. But there's an uncertainty in that measurement, and that uncertainty would allow for a universe with very slight positive curvature and for a closed universe. But because the curvature would have to be very slight, it means that the kind of the hypersphere that such a universe would be on would be so vast that our observable universe would be a very tiny fraction of that greater universe. And I don't remember, but I think there are at a minimum several hundred volumes of, is it several hundred or several thousand? I need to, it's of that order, somewhere in there, that the greater universe must be at least that much bigger than the pocket that we can see, the universe within our cosmological horizon. And so then the amount of mass in the Big Bang is at least, that much times hundreds to thousands of times the mass in our pocket, but it could also be infinite, much larger or infinite. And that's the answer.
Clay responds, so like if the universe is closed, will we collide with matter moving the opposite direction at some point?
No, unfortunately. Nor can you travel all the way around and get back to where you started, Pac-Man style, because unfortunately the universe is expanding and beyond our cosmological horizon, it's moving away from us faster than the speed of light, and it will keep expanding and keep expanding faster and faster, thanks dark energy. So if the universe were static, if it stayed the same size, then things could travel around and meet up again. But as it is, it may be finite, but it's still impossible to explore the whole thing. Which kind of seems like a bummer. I don't know.
Huge bummer.
Huge bummer.
Yeah. One of the great quandaries of existence is the realization that you will never be able to know everything.
Sail around the universe.
What's that?
Sail around the universe is impossible. That's the bummer.
That's the hugest bummer. There was a really good unreleased VR episode that touched on a lot of those points. Matt, do you remember that one? That it never got finished because we ran out of time. Some of the visuals were great though. What?
Yeah, it was cool. It was very
You're
cool.
like, I'm glad it wasn't all that great.
It was very cool. Sometimes I like to just sit and watch the half-done episode, a tear in my eye.
All right, smartass.
Late at night. It was very good.
The struggle of the artist, Matt.
What's that?
The struggle of the artist, trying to get funding for your passion project.
Yeah. And I think someone up there asked if we're going to do more VR. We have some ideas, but it's a long way off. But if it happens, they'll be, I think, quite a bit more amazing than what we did already.
We learned a lot then, but it all depends on, like everything, funding. So, but we have some requests out there and some wheels in motion to see if people will support it, and then we'll see what happens. There should be some interesting additional space-time kind of content expansions across some different media worlds in 2019, and we hope to be able to share more in the coming months as things kind of fall into place funding wise. But in the meantime, we are going to keep making awesome YouTube episodes. Just checking to see if there are any more questions that we should touch on. Clay Upton takes a positive side. Yeah, on the positive side, there's always something for humans not yet explored. I mean, what would we do if we had all the knowledge in the universe? We would strum guitars and drink martinis. I don't know. Do heroin. I don't know. What would we do with ourselves? I have no idea.
Yeah. Can I do Stuart's question?
Do it.
Hi from Kiev. Hi, Kiev. What do we make of the recent fast repeater signals? So these things are weird. Graham, are you also familiar with these?
Only that that's aliens, right?
Yeah,
that's my understanding.
right.
But not the history of them as such.
So these are so these were energetic bursts of gamma rays and other radiation that were previously thought to be explosive, as in a single burst, probably from some sort of stellar event, some sort of merger, I believe. Is that right? Merger of stellar remnants, or am I misremembering? Is it a supernova? Well, anyway, apparently it's neither, because the original idea was that you have this this burst of electromagnetic radiation that is somehow channeled into a jet, presumably by magnetic fields, because magnetic fields are responsible for pretty much everything mysterious, unless it's aliens. And so they channel into a jet, and that jet, if it happens to be pointing at us, you get this massive amplification of the radiation, of the brightness. Okay, so we'd see these flashes here and there, but then we started to see ones that repeated. Okay, what sort of explosion repeats itself? And so our original ideas of it being something related to the death of a star or some sort of merger had to be wrong, or at least some of them, had to be some sort of ongoing, continuous event. And so I'm actually not up to date on what the latest ideas are, except that I know that our good friend Avi Loeb of Oumuamua must be an alien craft fame also thinks that these repeaters are aliens. So I don't know. Actually, this is just me whining. Actually, it's not aliens. Avi Loeb's a hack. I think it annoys me slightly, because it sort of takes attention away from what could be an extremely cool astrophysical event. What is certainly an extremely cool astrophysical event. And if we just say, well, if it's aliens, it's cool, but if it's anything else, it's not cool, then yeah, it's my little gripe on that issue.
That's actually a really good point. That yes, everybody wants there to be aliens, but if the value of something hinges on it, then he really is doing a disservice to science and to the public's understanding of it and appreciation of it. Like,
there's actually kind of a related problem in science in general, which is that publishing negative results isn't sexy, and so there's not a lot of it done, and there really needs to be more verification and things like that, especially in medical science, which is different. But if you do a study once and no one checks it, do you really believe it? And it's useful to report things that didn't work, but it's hard to get grant funding for that. So it kind of makes only positive results worth doing.
Right. Unfortunately, physics and astrophysics don't quite suffer from that to the same degree as both medical and all biological sciences, where it's actually very hard to get null results published. In this case, I think physics and astrophysics suffer from another issue, which is that for some reason physicists want public attention, and that's my reading of people like Jamie Farnes and his dark fluid, and Avi Loeb and his Oumuamua is a light sail, and these gamma ray repeaters are alien. I feel like there's this desire to do press releases and get interviewed and stuff like this. Come on, guys, just start a YouTube show like normal people.
Yeah. That's what we're here for, right? To keep everyone honest.
Maybe one more question from David Bethala says, question about the recent episode on dark energy, dark matter. Is it still valid to base theories of gravity and universal expansion on Newtonian laws of gravity without factoring in general relativity?
What did you?
It's in the chat.
I'm going to say no, but I'm going to say no. You can sort of construct the Friedman equations with Newtonian mechanics. You can do it. And so you can get some of the same results, some of the correct results, but for a full understanding, you couldn't, for example, talk about the geometry of the universe with Newtonian mechanics.
I'm just catching up on the chat, and David Leonard says Oumuamua is aliens, but not the repeaters. I'm sure that we could talk more about that.
I'll split the difference with you, sure.
Yeah, exactly. That's the final bet.
Dustin Edgman says it's a good thing to have people like that out there making bold claims about aliens, as it gets people talking about science, and hopefully people like you, Matt, step up and give people more info. So
yeah,
good to have provocateurs.
Maybe it makes people like me look like whiny buzzkills.
Yeah, no fun Kermit without imagination.
Yeah, it's never aliens.
Stuart says, would a spinning Dyson sphere be discernible from a fast repeater?
I mean, aliens can make fast repeaters, sure.
And they can also make spinning Dyson sphere.
Sure. I think an alien could make could use a Dyson sphere to power something that looked like a fast repeater.
But I think Matt, when you make comments like that, it's not that you're being a snarky jerk. It's that it's completely speculative as to the possibility of ever being able to make a technology like a Dyson sphere. And so just by asking a question like that, you're assuming that a pretty low probability event has happened, right? And that's kind of like, it's like a fantastical question almost.
Yeah, in the case of the fast repeaters, so because the light from these things has to be beamed to such a small angle, we only see a tiny fraction of them. And so you can actually figure out how many alien civilizations there would need to be in our galaxy for us to see the number of fast repeaters that we do. And it turns out there would need to be, I actually calculated it based on Loeb's old paper, and it was many thousands. The nearest one would be within a few hundred light years. Our galaxy would be swarming with super advanced civilizations in order for us to see the number of fast repeaters that we do. And R.P. Loeb knows this. He did that calculation. He didn't talk about it in his paper because, it's counter to his argument, I guess. And I think in the same way, anyway, blah blah. There are usually good reasons there are usually ways to assess these outlandish statements beyond simply saying that they're outlandish, and that is the case with fast repeaters, with Oumuamua, with dark fluid. There are pretty simple arguments against that typically aren't addressed, and it seems suspicious that they aren't addressed. And I think it points to the motivation of some of these authors. Buzzkill.
How did they get a job at Harvard? How did they become heads of departments?
That's the thing. Avi Loeb is a fantastic astrophysicist. He's incredibly prolific, and he's done some important work, some really important work. So it's, you know.
So you just have to do some good work, get some cred, and then you can just say whatever crazy bullshit you want for the rest of your life.
Yeah, it's the Penrose effect.
Yeah.
It's the Penrose effect. Well, the difference here is I think that Roger Penrose really believes his own quackery. I don't think Avi Loeb believes his some of his crazy stuff. I think it's possibly attention seeking.
Trolling.
Yeah, I agree with
attention seeking.
I agree with Shannon. You just get tenure and then you do whatever you want.
Yeah.
I mean, that's why Matt works so hard to get tenure.
Yeah, I would never speak this way against Avi Loeb if I didn't have tenure, because he could destroy me.
Stuart still hopes it's aliens. I still hope it's aliens too. I mean,
I want it to be aliens.
We all want it to be aliens, you know? Like, all right, we're out of time. Thank you, everybody, for the great conversation as usual, the great chat. Thank you, Matt and Graham. Thank you, Jens, for joining us.
Thank you, guys.
Being the lone supporter on the Hangout, you did well.
Yeah. Next
You
week.
managed to keep your nose the whole time.
Yeah. Next week there'll be some others, right?
Yes. Should be.
It's the slow time of year.
Oh,
but
okay.
I'm going to be having nightmares about these gigantic black holes. Thanks, Jens.
Graham wants to do one more question to go out on, which is, what's the most interesting topic you want to do a space-time episode on? Why don't you both take this one separately?
Matt first.
Wait on. What was the question exactly?
What's the most interesting topic you want to do an episode on?
Interesting. God. I mean, there's some stuff that, some of the stuff I said earlier, I'm excited about doing. I decided this morning I want to do baryon acoustic oscillations. So
cool.
the sound waves propagating through the early universe. And maybe we'll shoot that next week if I can pull it together. I also want to do some more meta stuff. I want to start looking at some of these ridiculous notions and pick them apart in not a snarky way, hopefully, but in a kind of a more analytical way. So some of the quantum woo-woo ideas that you see out there, I think it would be really nice to discuss some of this stuff in a kind fashion, as opposed to
The episode will be why quantum woo-woo is full of shit in a non-snarky way.
Yeah.
Exactly, which is a huge challenge.
Deepak Chopra
and maybe
deconstructed.
Yeah. So if it makes sense to do that, I would like to do that, and some other scientific mysticism stuff too, perhaps.
We were talking
What
about
about you?
metacognition and thinking about thinking, and that's kind of an interesting way to intersect with those things. Of like, well, how do you evaluate like whether something should even be considered in part of the dialogue or not? And
Yeah.
And how
Yeah,
should lay people know? You know, I think that's a challenge. Is like, because lay people, they don't have the kind of sophisticated understanding and ability to parse good science from bad science like you do. You know, so it's
Exactly
really
right.
tough.
Yeah, that's exactly right. I think there are some skills that we take for granted in, you know, and not just as scientists, but reasonably well educated folk take certain skills for granted, and even in taking them for granted, sometimes don't know when they're not exercising them, and so, you know, we'll stick to physics and astrophysics, but I think we can address some of these ideas.
Graham,
In that field.
what are you most interested in doing an episode on?
I was going to suggest something slightly narcissistic, which is the stuff I used to work on because I think it's super cool, which is, well, one of them, which I need to understand first before we can write anything about it, is usually a good step, is the spin statistics theorem, which sounds sort of esoteric and weird, but it underpins, and it gets a brief shout out in the CPT episode that just came out, but it basically underlies the difference between fermions and bosons and tells you why they behave so differently. And it has some weird proofs with it. But I think things in atomic physics and molecular physics, not so much because of the, but basically the structure of atoms and molecules and how we know what we know about them in terms of how do we did the episode on the G factor. Yeah, how do you do that calculation? What does that really mean? And there are some really cool, but also with variation fundamental constants, there's huge amounts of cool stuff there about how do you even predict what this change would be when you want to compare to the measurement, stuff like that, and density functional theory and all these other weird things. There's a couple there that are, the statement is non-intuitive and really cool and kind of easy to discuss, I think, at a fairly accurate way, even in a sort of 15-minute video. There are some really interesting, surprising results.
Yeah, I'm excited for this too, because I think one thing we don't do is talk about how physicists actually do physics. You know, they don't just write down the Schrodinger equation and, you know, 5 steps later have the standard model. There's all sorts of ingenious tools and tricks along the way.
Yes, Graham, physicists use memes to.
Yes, that's right. that's the unit of information that we use. We simulate the world, and the observable output of those simulated universe is memes, and that's how we judge how accurate the simulation is. It's if we get dank memes out of it. But this is related to the point about the simulation before, about doing, do you include dark energy and dark matter when you do these cosmological simulations? And I think it would be really cool to discuss stuff like the Millennium simulation, because if you see some pop science article that says, oh, they did a simulation and this was the outcome, and they show a cool picture, there's loads to talk about there, about what it actually means to do those and what the physics that goes into it is and what the physics you get out of it. There's a lot glossed over, I think, in sort of some simple sentences and a picture that I think people would be really interested to learn, I think. We'll see.
All right, let's wrap up. Thank you, everybody. Thank you so much for supporting the show. We as always are very, very grateful, and it's what makes it possible. I'll always say it, but PBS continues to support Spacetime, by and large, because Spacetime has such an amazing fan base and such a great Patreon. So we are so grateful, and I hope you will be in touch with us. If you ever have great ideas, shoot us a message through Patreon. It gets to me and Matt right away. We want to know what you think will make the show better and what you want to see. And, so just be in touch with us. We're here to make awesome stuff for you. Matt, Graham, any closing thoughts?
No, just to say thanks as well. It's really cool to read through the YouTube comments in particular, in addition to all the awesome support from Patreons and these cool questions, just to see people kind of happy to be a little bit confused by the topic and then watch the video a few more times and then get it. That's really satisfying as the people that write it and make it, because it's not easy stuff, and to see people stick with it and be appreciative of the fact that it is a little bit more technical is really cool. I really appreciate that. It's awesome.
Yeah, so well put. And to see people learning in the comments and learning with us and helping each other learn, and giving us the excuse to delve into some of this incredible stuff. It's insanely satisfying. So here's to a 2019 full of more incredible secrets of reality. Happy New Year, everyone, by the way.
Oh, yeah,
I
it's
think I
New
said
Year.
it.
When you get older, you stop paying attention to these things. Bye. Have a good night.
Yep. Thanks,
Farewell.
everybody.
Farewell.
Good night.